Assalamualaikum and hi. Today our group will be presenting about electric transportation and to be specific, electric car. So here is our group member. Rani Sahana, Isma Hasiba, Nik Shahidatul Halifa and Nur Ali Akila. So for the introduction, electric vehicles are another name for electric cars. These are vehicles that use electrical energy stored in rechargeable batteries to power one or more electric motors. Compared to vehicles with traditional internal combustion engine, electric cars provide a variety of benefits. The quieter operating of this vehicle, which offer a more pleasant driving experience, is one of its best features, which is why everyone wanted to own it. We can learn an immense amount about electric cars.
In this slide, we will explore the relevant electricity and magnetism concepts on the electric cars. First of all, electric circuits are essentials in electric cars by carrying electricity from the battery to the motor and other parts of the car. The circuits manage and regulate the flow of electricity to ensure smooth operation. Besides, circuits include protective devices like fuse to prevent damage from overcurrent. Thus, electric circuits ensure everything in the car gets the right amount of power to function properly. Next, Ohm's law is the relationship between the voltage, current, and resistance in electrical circuits, which is V equal to IR. Ohm's law states that the flow of electric current through a conductor like a wire depends on voltage and resistance. In simple terms, Ohm's law helps us understand and control the flow of electricity in electric cars, ensuring that the motor gets the right amount of power and the battery charges safely. Moreover, batteries store electrical energy, which is essential for powering the motor. The charging and discharging of batteries depend on electrochemical principles. Additionally, in electric vehicles, capacitors are integral components that leverage both electricity and magnetism to improve energy storage, power management, and the efficiency of various systems. Capacitors help store and release energy quickly, manage power smoothly, and support charging. They use electric fields to store energy and are important for making the car run efficiently and reliably. Next, regenerative braking is a key feature in electric cars that helps recover energy when the car slows down. Electric cars use electromagnetic induction to convert kinetic energy back into electrical energy, recharging the battery during braking. Regenerative braking helps extend the driving range of electric cars by recapturing some of the energy that is usually lost during braking. Furthermore, electric cars use electric motors that rely on electromagnetic induction to convert electrical energy into mechanical energy to move the electric cars more efficient and sustainable. These motors work based on the principle of electromagnetism. In short, electromagnetism is at the core of many systems in electric cars, from the electric motor to power conversion and even charging systems. Moreover, charging systems is the process of transferring energy from the grid to the car involves concepts like voltage, current, and resistance. These concepts of charging systems is like fast charging and smart charging. Next, magnetic flux is the amount of magnetic field passing through a surface. In electric motors, magnetic flux is involved whenever magnetic fields are used to create or manage electrical energy in the car, whether for moving the car, charging the battery, or recovering energy during braking. Besides, magnetic fields are key to how the electric motor works by creating forces that turns the car's wheel using the combination of electricity and magnetism. Electric vehicle EV depends solely on an electrical motor for propulsion and use only electrical energy to supply the vehicle, which means it has zero emissions. Last but not least, permanent magnets are unique in generating their own constant magnetic field. As their magnetism is always on, they are widely regarded as the most effective method to power electrified vehicles. The magnetic field these magnets emit oppose that produced by a coil. This repulsive effect causes the coil to rotate at high speed and when attached to the axle of a vehicle, creates motion.
Next is exploration or technology of application electric cars. First is battery technology. Batteries are the cornerstone of electric car technology, determining range, charging speed, and overall performance. First is solid-state battery. It replaces liquid electrolyte with solid material for increased energy density, faster charging, and improved safety. Second is lithium iron phosphate. It offers lower cost and greater stability, increasing use in EVs like Tesla standard range models. Third is recycling technology. Closed-loop system recover lithium, nickel, and cobalt to reduce mining deficiency. So the second one is electric motor. Electric motors convert electrical energy into mechanical energy to drive the car. So there's three types of motors. First is permanent magnet synchronous motor. It is efficient and widely used in EVs like the Tesla Model 3. So second is induction motor. It is durable and reliable, utilized in early Tesla models. So the third one is switch reluctance motors. It is emerging for cost reduction and high efficiency. So the third one is power electronic. Power electronic manage the energy flow between components, optimizing efficiency and performance. The electronic design for such application have been developed through years of innovation to allow the battery to operate the car. Unlike the mechanical component of an ICE, EVs are operated by switch, passing instant message between components to achieve rapid response between them. So the fourth one is composite materials. It is advanced in material enhanced EV efficiency and reduce production costs. First is lightweight materials, for example, aluminium, carbon fiber, and high-strength steel reduce vehicle weight, improving range and efficiency. Second one is aerodynamic. EV design emphasizes minimal drag coefficient, crucial for optimizing range. For instance, the Tesla Model S boasts a drag coefficient of 0.208, one of the lowest in the market. So next is example of real-world implementation. First is Tesla Model 3. It is widely popular for its affordability, long range up to 358 miles, and high performance. So the impact of Tesla is Tesla vehicles have LED the shift toward EVs with over 1 million Model 3 units sold globally by 2023. So next is Nissan Leaf. It is one of the first mass-market EVs known for affordability and reliability. It's over 650,000 units sold since its launch, popular in regions like Japan, Europe, and North America. So the third one is Hyundai Ioniq 5. It is retro modern design and 300 more mile range and fast charging. So the impact of it is a competitive EV with a broad appeal, supporting Hyundai's goals of becoming a leading EV manufacturer.
There are three benefits of electric cars. First, environmental impact. Electric cars are environmentally friendly because they produce zero tailpipe emissions, unlike traditional vehicles that release carbon dioxide and other harmful gases. By relying on electricity, especially from renewable sources like solar or wind, they significantly reduce air pollution and help combat climate change, making them a cleaner and greener transportation option. Next, second is lower operating costs. The operating costs of electric cars are lower compared to gasoline-powered vehicles. Charging an electric car is much cheaper than refueling with petrol, and they require less maintenance due to having fewer moving parts, without the need for oil changes and with slower brake power from regenerative braking. Electric cars offer significant long-term savings. The third benefit is energy efficiency. Electric cars are highly energy efficient because their motors convert a larger portion of energy into motion compared to internal combustion engines. This efficiency means they use less energy overall while providing the same performance, making them a more sustainable and effective transportation choice. There are several challenges of electric cars. First is charging infrastructure. A major challenge for electric cars is the limited availability of charging stations, particularly in rural or less developed areas. While urban locations are improving, long-distance travel can still be difficult without sufficient fast charging stations along highways. This lack of widespread infrastructure leads to range anxiety, where drivers fear running out of battery power and are hesitant to adopt electric vehicles. The second challenge is high initial cost. Electric cars tend to have a higher upfront cost compared to traditional gasoline-powered vehicles, primarily due to the expensive lithium-ion batteries and specialized components they require. While operating and maintenance costs are lower, the high purchase price remains a barrier for many potential buyers, especially in areas where government incentives or subsidies are limited. For the third challenges is battery limitations. Over time, the batteries in electric cars degrade, reducing their capacity and performance. Most batteries need to be replaced after 8 to 10 years, which can be a costly process. Additionally, the production of these batteries raises environmental and ethical concerns, such as the mining of raw materials like lithium and cobalt, which can have significant environmental impacts and human rights issues.
Now, I will be talking about the future development and innovation of electric car. These include their strengths, weaknesses, opportunities, and threats. Electric vehicles or EVs are a crucial step towards sustainable transportation, and they are rapidly shaping our future. Let's begin with the strength. Electric cars help prevent air pollution and climate change by producing zero emission during operation. For example, cities like Oslo, Norway have seen improved air quality due to a high adoption rate of EVs. Efficiency and innovation. With advanced capabilities such as AI integration, clever design, and modern battery technology, EVs provide a better user experience. Features like regenerative braking also improve efficiency. Electric motors are more effective at delivering rapid horsepower compared to internal combustion engine. A great example is the Tesla Model S Plaid, which can go from 0 to 60 mph in less than 2 seconds. EVs operate much more silently than traditional cars, making urban areas quieter and less stressful. Now, let's look at the weaknesses. EVs have high starting costs because of expensive battery technology. For example, a Tesla Model 3 can cost significantly more upfront compared to a similar gasoline car. EVs typically have a shorter driving range than regular cars. For instance, a Nissan Leaf can travel around 150 miles on a full charge, while a traditional car can exceed 400 miles with a full tank. Equipment for charging is still in its early stages, particularly in rural areas. Drivers often have to plan their routes carefully to avoid running out of battery. Battery production relies on rare materials like lithium and cobalt, which raises concern about sustainability and ethical sourcing. Despite these challenges, there are exciting opportunities. Advancement in battery technology can improve performance while reducing costs. Solid-state batteries, for example, are a promising solution that may revolutionize the industry. With the expansion of fast charging networks like Tesla's superchargers network, EVs are becoming more convenient for long-distance travel. EVs are often at the forefront of autonomous vehicle technology, offering opportunities to transform transportation systems. Companies like Waymo and Cruise are integrating EVs with self-driving capabilities. Electric buses and trains are gaining popularity, offering a cleaner alternative for mass transit. Cities like Shenzhen in China have fully electrified their bus fleet. Finally, let's discuss the trend. Established automakers are entering the EV market, increasing competition. For example, Ford and Volkswagen have launched their EV lines to challenge Tesla's dominance. Shortage in essential battery parts such as semiconductor can delay production. Next, changes in government law and subsidies could slow adoption. For instance, if subsidies for EV buyers are reduced, some consumers may hesitate to make the switch. Next, low infrastructure development and a lack of awareness about EV benefits still pose challenges in certain regions. In conclusion, electric vehicles have enormous potential to transform the automotive industry and contribute to sustainable future. While challenges like high cost and infrastructure limitation remain, ongoing innovation in battery technology and autonomous driving present exciting opportunities. The transition to electric car is not just an environmental necessity, but also an economical and technological revolution. In summary, compared to traditional internal combustion engine vehicles, electric automobiles provide a cleaner, more environmentally friendly and highly advanced alternative, making a revolutionary shift in the automotive industry. Advances in battery technology, a shared awareness of environmental issues, and an ongoing effort by automakers and government to build a more sustainable future are the main drivers of the trend toward electric vehicles. Essentially, electric vehicles also represent a significant advancement in the direction of a more environmentally responsible and sustainable transportation system. As automobile technology advances, a more environmentally friendly mobility environment will be projected for the generation to come.